All right, so we're still here at Little Bear Lake, and I'm just going to show you how we measure snow depth, the other part of measuring snow water equivalent. In the earlier days, you could just use a regular stick with some sort of graduation on it and record the depth. But now we have a bit more streamlined way to collect snow depth, and it's using an instrument called a magna probe, developed by a snow scientist, and he builds them on order. They cost about $5,000, and they do two things. They measure snow depth and they record GPS signal. And the way that they work is that there's this sliding disc on this metallic pole with some magnets in it, and there's a sensor in here which can measure the distance this is away from the rod, and that's how you get your snow depth, because you know the total length of the rod. So when you push this button right here, it'll record the snow depth, and also here is a GPS signal, or a GPS antenna, that'll record the GPS position of where you took that snow depth, which is important to know. You can see when we get over there, you'll see just how quickly snow depth can change from 10 centimeters up to a meter, not very far. So in the backpack, we have the data logger, which is just a regular Campbell data logger that you would use to run a MET station or soil moisture station or any other instruments. These are really common in the science field. And here we have the two batteries, and up here is the little component which is measuring the GPS location. So as you can see, it's pretty kind of jerry-rigged together, but there's not much a ban for snow measurement instruments, so it really beats having to just use a stick and a ruler and take your notebook out and write it down. And we also have a device here where we can enter in more data. If we have a snow depth which is greater than this, we can go in and enter it in here if we want. We're not going to bother with that today though. Put that back in there. This backpack's fairly light. It probably only weighs 5 kilos or so. It's quite comfy. And you can do probably 1,000 or 2,000 snow depths depending on where you are in a single day. I'll just go back over to the drift where we were measuring. So yeah, today is April 21st, and it's unseasonably warm. I think average high should be about -8 or 9, maybe -5. And I think it's going to go up to 2 or 3 today. So you can see I'm in a t-shirt. When it's sunny like this and there's no wind, and you have this really high albedo snow which is reflecting a lot of the sun's energy, you get pretty warm, especially when you're doing work and walking around all the time. So I've been doing transects up and down this drift, as you can see, and I'm just going to start going again. So all we have to do is make sure it's at the ice level, and we hear 3 beeps. The first beep is to say it recorded a snow depth, and the second 2 beeps are telling me that it had a GPS position. So you know you're getting data. You don't go and collect a bunch of data and then figure out, oh crap, I wasn't actually reading. The beep's kind of annoying, but it tells you that you're recording data. So you can think about how much faster this is, where in the old days I would have to go and put the stick in, read the number, take my notebook out, write it down, continue on. This really speeds things up. And you can see we're getting into some pretty deep snow already. And you can feel the ground. It's just a little bit squishy. Sometimes you'll hit hard layers in the snow, but they feel more like ice. You try not to go too far into the ground and read a deeper snow depth than actually exists. There's Dilshan back with some food. Yeah. But really grateful that this instrument exists and we have some. It makes snow surveying a hell of a lot faster than it used to be. And it's also good for our drone product. So we use our drone and fly it all over the basin, and it measures the surface of the snow. When we subtract that from the surface of the ground, we get snow depths, and we can use the GPS recorded snow depths that we take here to validate the drone measurements. Whereas in the past, you would have to take down your snow depths and your GPS measurement separately. So we're at the top of the drift. It's starting to get a bit shallower now. That's my line there, that tree, so I'll go over a few paces and start going down. And we typically survey different types of landforms, so snow drifts, lake ice. You can see some taller shrubs here which are protruding through the snow. There's some areas in the uplands there where there's no shrubs. And where there's no shrubs, the snow is typically shallower because the shrubs are able to catch some of that blowing snow. There's nothing to stop the wind here, so the wind and the topography and the vegetation are really the things which are controlling snow depth. And the shrubs are growing taller and covering larger areas in the Arctic, and that is causing changes to the snow redistribution because the taller shrubs can catch more snow, but they're also protruding through the snowpack more. And on days like today, those dark shrubs heat up and they emit long wave radiation, and they start to smelt the snow a bit faster than it would usually. So we can just see it starting here. You can see around the shrubs all the snow is melted there, and that will, as the snow melt goes on, this whole area will start to preferentially melt compared to there. And of course, as it melts, you're getting further down in the snow where there's more twigs, and that accelerates it even further. So yeah. And in a recent paper from here, which is in review, we found that these areas of shrubs, where the shrubs are protruding through the snow and they cause the snow to melt about a week earlier, you actually have deeper frost table depth. So the shrubs are melting the snow earlier and potentially will cause the permafrost to thaw as they grow taller. Here you can see a really good example of how just a little bit of exposed dark vegetation can really preferentially melt things. It's still below zero right now, but the sun is so intense that it's able to heat up these dark surfaces, and that's just enough to cause the snow to melt. If I touch this, it's not cold, but it's not warm, but it's definitely warmer than the snow, and it's definitely above zero.